And we're back. Excellent. I always imagine that when I go live with these things, the moment that I go live, there's a collective cheer heard throughout the streets of Barnegat. I can hear it out the window. They're just chanting something about math. I'm not really sure. Anyway, we're back. Yes. Okay. Now, we do have a bit to do, so let me give you a brief update, rundown as to what's going to be happening. And then I'll tell you what we're going to be doing today, and then we will implement all of that fun, miraculous stuff. So first and foremost, I am almost done grading all of the assessments that you guys turned into me this past week. I got very much behind because of the schedule that they have us doing after school with meetings and whatnot. For example, yesterday I was in a meeting for an hour and a half on my computer with other teachers throughout the building doing kind of pointless stuff, but we had to do it regardless. So that's where we're at. Anyway, beyond that, I am almost done with those assessments. Number two, you do have a page out of the textbook due for me today, I believe, at 2 o'clock. I'm just double checking that it was today. Yes, it was today. Page 167. Obviously, I will expect that, and we'll be looking through that. Now, big thing. And I was kind of waiting, 726, 727 for people to kind of join. And I am going to be reminding you of this throughout the class period, of course. But I am going to be assigning you something today that will count as a major assessment. And I'm being very deliberate with my words because I want you to be able to hear what I'm saying. This major assessment will be due Monday by 7 a.m. It will be due Monday by 7 a.m. And of course, I will put that big reminder in the directions as well. This major will consist of two things. There will be a multiple choice component, which I am going to run through quizzes. And there will be an open-ended component, which you will write out and submit to me. Now, with this open-ended component, being that we are doing linear regression, there are times in which they do ask for you to produce a scatter plot, which I'm not really a huge fan of people having to spend all of that time drawing out painstakingly a scatter plot. Now, if a histogram is a different story, a pie chart's a different story. A scatter plot, it's like, oh, I got like 50 points to plot. Okay, that's not. So, with that, you will be allowed to create these scatter plots in your graphing calculators that are on your Chromebook. So I just wanted to briefly talk about this right here. This is a just in case you did not already know how to do this, because there are people who do know how to do this, and I will put this in the instructions as well. But you can create scatter plots on your graphing calculators on your Chromebook, and then you can take screenshots. Control, Shift, this button up here. It's like the, I forget exactly what this one is called, but it's like it switches between windows and stuff like that. But it's actually pretty simple to take a screenshot. The Chromebook takes the screenshot and then automatically uploads that picture to your Google Drive. I couldn't even think of the word right now. Yeah, it uploads it to your school Google Drive. So you would have the opportunity to capture screenshots. Now, if you have a better way of kind of doing it, that's completely up to you. If you have a way of kind of editing the picture down, that's up to you. But I'm just giving this very basic example. If you need to create a scatter plot using the graphing calculator on your Chromebook, Control Shift, and then this button up here allows you to take a screenshot, which is really nice. A lot of people know how to do it, but surprisingly, a lot of people don't. Anyway, just recapping for those who may have joined a few minutes late. In the middle of grading the minor that you guys did for me this past week, I'm going to have that submitted today. Number two, you do have a page out of the textbook that is due today by 2 p.m. And I am going to be assigning a major, which is going to be due Monday at 7 a.m., which is going to consist of a multiple choice component on quizzes, and it is going to consist of a free response that you would have to write out and then take a picture and upload that thing. But of course, any scatter plots you can do directly on the Chromebook graphing calculator, screenshot that sucker, and you can get that thing up into whatever it is you're submitting to me. Yay. Anyway, get this thing off the screen. It's bothering me. So, my ultimate goal for today, I do have a quizzes that I would like to practice with you today. Multiple choice quizzes are the best, just because, again, half of your AP test is made up of multiple choice questions. But I do have a practice quizzes that I would like you to do today. But before we do that, there is some additional information that I would like to get to you in regards to linear regression. Now, this information is not needed for the major that I am going to be assigning you today. The additional information that I'm giving you is not needed for the major that I am assigning you today. But it's information that is helpful, that rounds out a lot of what we're doing with linear regression. So if you would, ladies and gentlemen, if you do not already have them out, why wouldn't you? I'm going to need those notebooks out and open. All right. Zoom it out. There we go. Okay. Now, unfortunately, there's no real new title to this. It's Linear Regression Continued. There are multiple chapters in the book that are dedicated to linear regression. Chapter starting with 6 and 7, the ones that you read for me leading up to this, they just kind of introduced the concepts of scatter plots and association and lines of best fit, and then the next few chapters show the calculations on how to do it, and then eventually we're going to get into something called regression wisdom, which is okay, that's cool. And then eventually the big end to the unit is rescaling data, which again, we're gonna get there. Okay. Today is the 3rd. There we go. That's weird. 3rd. There we go. And unfortunately, I don't have a new title for you. I'm just gonna call it LinReg Continued. All of these chapters kind of bleed together. And I'm okay with that. You're probably not okay with that, but I'm okay with that. Just because I need to get you this information. Now, the beauty of this whole thing, just so you guys are aware, I'm going to zoom in on this. Don't worry if you, obviously with your graphing calculators, they automatically reset when you close them and reopen them. So you most likely do not have this data from last class. Don't worry about it. I'm not going to spend the time to have you re-enter the data. I'm just going to kind of walk you through some of this stuff so you can see what I'm referring to with the residual graph. It's unfortunate that I cannot just be like, hey, let me just share this data with you with a cord so you don't have to type it all back in. But no, unfortunately, I can't do that right now. So anyway, we left off last class talking about the residual plot. You can graph a, quote, residual plot, end quote, by changing the y-list to resid. And I will walk you through that again today in a few minutes. I walked you through a little bit last class, but I'll walk you through that again this class, just so we're all on the same page with this. But you can look at the residual plot by changing the y-list to resid and then looking at a new scatter plot, so to speak. Star. Now, I have said I do not put many stars in my notes. I don't. I try not to. So this is a big deal. If a linear model is a good fit I talked about this last class, but I did not actually write it down. And obviously now we are writing this thing down. But if a linear model is a good fit, or another way of putting it, appropriate. If a linear model is appropriate, then the residual plot will appear to be scattered. I need to get a new marker in a moment. No pattern. I'm going to reread all of that. Just got to get rid of this marker. Oh, no. Come on, marker. Oh, let's just say I made that, but know that I missed terribly when I threw that marker. Anyway, if a linear model is a good fit, meaning that it is appropriate, then the residual plot will appear to be scattered, meaning no pattern. This is very important because you could run through an entire process of linear regression. You could hit all of those assumptions and conditions. Be like, okay, well, it was quantitative data. Yes, we're good. Awesome. Fantastic. Was it straight enough? Yeah, it appeared straight enough. Good. Okay, cool. Were there any outliers? Well, yes, there was one outlier, especially in the data that I have for you today, but we're going to run the linear regression without that outlier as well, which is what a good statistician does. Okay, fantastic. What about the residual plot? Ooh, new wrinkle. You have to be able to look at the residual plot. And the residual plot will be the definitive marker as to whether or not a linear regression was appropriate or not to perform. This is what we must do. So now let me walk you through again what the calculator did. Let me walk you through again what the calculator did last time. I'm going to focus the screen in a moment. Come on, screen. Yes, there we go. Good. So last time I gave you this data. It was based on terabyte capacity, or the capacity measured in terabytes, and the price of purchasing said capacity. And this is what I wrote into L1 and L2. Now, seemingly, just looking at the scatter plot, it all went away. Looking at the scatter plot, which I'm going to go back and do now. Second y equals, turn that plot on. I'm going to put it back to L2 because I would like to see the original scatter plot. This is the original scatter plot. Let's make sure my y equals key is cleared. There we go. Zoom 9. Boom. This was our original scatter plot. And our original scatter plot appeared to be straight enough. It was based on quantitative data. And yes, there appeared to be an outlier all the way up there. Now, it's okay if we have that outlier. That outlier does not disqualify you from running a linear regression. It doesn't. What a good statistician does is they run the analysis both with the outlier and without the outlier. And that is exactly what we're going to do today. I'm just going to write some peripheral information on the board. So let me run this regression. Oh, I wonder. There it is. Now, I never reset my calculator. Because I wanted to keep this data for today. But just in case, especially with your calculators, you need to make sure that your diagnostics are on in order for your linear regression to produce the R, which is the correlation coefficient, which measures the strength of the linear relationship, R squared, which I have not given you information on just yet. And it also calculates the residuals, which is the vertical distance between the observed data point and the predicted line. We're going to get there. It's going to be great. So let me run this linreg again. Stat, calc, linreg, L1, L2. Again, your interface is going to automatically say L1, L2. Boom. Okay, let me write some of this stuff on the board so I have it to compare. And again, I'm not putting this into my notes. I just wanted to compare it. This is with the supposed outlier. With the supposed outlier, we got y hat equals 142.18x minus 296.31. That is exactly what we got last time. I'm not going to worry about the r squared because I have, well, I'll round that up. I have the r. Well, Ms. Markey, how do they calculate r squared? Well, you calculate r squared by squaring the r. Okay, but literally that's how they calculate it. Now, r squared has a different definition. It has a different definition than r. We'll talk about that later. All you have to worry about right now is the fact that we have r, which is the correlation coefficient, which measures the strength of the linear association. Now, what I would like to do is I would like to remove this. Well, actually, you know what? Let me clear this out as well. Delete that. There we go. I just wanted to get rid of the residual plot graph there because it's going to recalculate it in a moment anyway. But I'm going to remove what we believe to be the outlier. We believe, based on visual evidence, that 32, 4461 was an outlier to this particular data set. And what a good statistician does is, well, now I'm going to remove it, and I'm going to rerun the linear regression, hoping to kind of see what kind of changes there are. And that's exactly what I'm going to do. First, let's look at the brand new scatter plot. Zoom 9. Boom. Oh, that is what we suspected kind of last time. I think I even verbally said this last time, that the data did appear to be slightly exponential. But is it straight enough? Yeah, it is. It is. Again, in the realm of statistics, you have to learn how to be fluffy. Fluffy means that we're going to have to bend that definition. Is it straight enough? It's a very loose kind of statement that they're making right there. But that should be sufficient. It's quantitative data. There do not appear to be any outliers. Let's run the linear regression. Stat, calc, lin reg, L1, L2 is automatic. Boom. Okay. Now this is without the outlier. I'm going to write it over here. Without outlier, we got y equals 89.29x, y hat, there we go, put a little hat on it, minus 80.97 with an r of 0.974. Now let me tell you what I see here before we look at the residual graph. First of all, the slope, yeah, it did change, but it didn't change too drastically. Yes, it went from 142 down to 90. It dropped, and that seems like a large number. Like it dropped like, 43? But it's still a highly steeped, positively sloped line. In fact, the y-intercept stayed negative. Yes, it did change, but the y-intercept changed because originally the line of best fit would be something like this, and then the new line of best fit would be something like this. It's fine. It should be fine. What's really interesting is the R. The R barely changed. The R barely changed. Barely. 0.974, 0.988. These numbers are almost identical. There's statistically speaking, there's no significant difference between those two numbers, the R values. It's very interesting. All right. We've run the linear regression. We have our R values. The calculator now has the residuals. Let's take a look at the residual plot because this is what you'd have to do. Second y equals, I'm going into plot 1. as per the notes that we just talked about, I'm going to change my Y list. Now, how does one change the Y list to resid? You hit second stat, which brings you to a list of lists. And I'm going to go down to the 7th option, resid, and put that in for my Y list. Now, what this is going to do is it's going to take all of the X values. It's going to take all of the X values and put them on a scatter plot with the Y values being all of the calculated residuals. Now, remember, there is a residual for every single data point on that scatter plot. It is the vertical distance between the observed data point and the predicted line. So if I were to take an X value and plug it in here, it would give me the predicted price. I would take the observed price minus the predicted price to get the residual. I'm going to zoom 9 it. Let's take a look. Zoom 9. Boom. Ooh, interesting. It's kind of scattered, but also kind of not. Is it scattered enough? Yeah, I'd say it was scattered enough. I mean, one could totally argue that's like, no, look, it goes, woo, it does like one of those. Yeah, but it would be a bit more obvious. It would be a bit more obvious. I mean, yeah, you could. This is one of those iffy problems where if you were running the linear regression and it was like, ooh, this one is really borderline, then you can say that in your conclusion. You can make that note saying, here's all of my analysis for the linear regression. Note, keep in mind that the residual plot appeared to be scattered, but one could argue that there is a pattern. This is the horribleness that is statistics, the fact that you could argue both sides of the argument. This is what happens. I love it so much. I love it so much. I'll show you a bit more obvious one. I'll show you a more obvious one in a little bit, but let's just stay with this one for now. Here's what I want to show you. I want you to visibly see what I'm about to show you. Check this out. Let me go back. To the original. Here's the original scatter plot. No outlier. I took out the outlier. I'm going to rerun that linear regression, but I am going to store the information to my Y1 key. There it is right there. I stored the equation to my Y1 key, and I'm going to graph it. And you can see the line is cutting through the data. Here's what I need you to see. This is the original scatter plot. No outlier. I took it out with the line of best fit. There are some data points that lie below. There are some data points that lie above. Okay, cool. It cuts through the heart of the data. It follows the trend of the data. Fine. This is what a residual plot does, though. As I said, a residual is the vertical distance between the observed data point and the predicted line. So this would be positive. This one's almost like right on there. This one's negative, probably a little negative, a little bit more positive. It is the vertical distance between the data point and the prediction line. What a residual plot is. Imagine for a moment, I'm going to erase this. Imagine for a moment that I had the ability to actually pick up this entire scatter plot. Just imagine for a moment that I had the ability to literally lift it off of the screen. Lift, turn it horizontal, and put it back down. Just imagine that for a moment. Imagine that I had the ability to lift it, turn it horizontally, and put it back down. Look at these data points. This one's almost right on the line. These two are above. These two are below, and this one's above. So it's like it's above on the ends, and it's below in the middle. Now let me go back to the residual plot. Okay, residual plot, change the Y list, zoom 9 it, boom. Oh, the line of best fit is still there. Get rid of you. Here we go. Look what happened now. These two are above. This one was above. This one was very close to the line, and the ones in the middle were below. It rescales the whole thing. Now, these actual data points, as I mentioned, look at the one blinking right there. That's 2, 14-point change, whatever. That just means that at 2 terabytes, here was the calculated residual. And that's what they plot. But it's the same scatter plot. All that they did was they lifted it off of the screen, they turned it horizontal, kind of rescaled it a little bit because of the residuals, and boom, put it back down. The configuration of the scatter plot is exactly the same. Sometimes they'll do that to you. Sometimes they'll do that to you where they'll give you a scatter plot and they'll say, hey, here's the scatter plot. What do you think the residual graph would look like? Here are some choices. And they'll do that to you because that's literally what's happening with the residual plot. They're just picking it up and placing it back down. But they're placing it back down in a horizontal fashion. It's wonderful. I love it so much. Okay. Go back to my notes real quick. A couple more things in the notes before we get to the quizzes that I would like to get to. So I want to update. I'm going to erase that stuff on the board in a minute, but I want to update our assumptions and conditions. There are certain conditions that we have to meet in order to be able to do a linear regression, to be allowed to check a linear regression or use that data and it be appropriate. So, to use a linear regression, conditions must be met. Number one, as we've said before, you must have quantitative data. You must have quantitative data. If you do not have quantitative data, then you are not allowed to run a linear regression. You cannot have categorical data. Number two, the scatter plot is straight enough. And again, I put that in quotes because straight enough is a very subjective standard. It is a very subjective standard. What the heck does it even mean to be quote unquote straight enough? What's your opinion? Sometimes it's more obvious than others. Number three, check outliers. Now, again, a good statistician is not going to declare that a point is or is not an outlier. A good statistician is going to run the analysis both with and without the outlier in order to determine if there were any major changes. Now, believe it or not, we removed that outlier and the line of best fit didn't change all too much. There wasn't a drastic change. There wasn't a drastic change to the R value as well. Now, yes, technically, you could consider that point an outlier based on something that we're going to be doing eventually with this whole linear regression stuff. There are some definitions that I have to give you in regards to what may or may not be considered an outlier, but I'm not going to touch those right now. I want to focus on what I need to focus on. That is going to be in the next few lessons. And now, brand new, number 4, residuals are scattered. The residuals must be scattered. You must check the residual graph in order for that thing to work properly. You must check the residual graph. So, for example, I'm going to reset my calculator real quick. I'm just going to reset it, and I'm going to enter in some brand new data. I'm going to enter in some brand new data. Let's see. Yeah. Okay. Good. And check that. Boom, perfect. Okay, look at this. This is brand new. You've never seen this before. Look at that scatter plot. This is a rhetorical question. Is that scatter plot straight enough? Yeah, absolutely. Yes, it is. Look at that. That's like, with a little, it looks really straight. I mean, not perfect. Let me run the linear regression. Oh, let me turn my diagnostics back on because I reset my calculator. I reset the calculator. I got to turn my diagnostics back on. There we go. I'm going to run the lin reg. Boom. Look at that. Look at that R value. That R value is incredibly strong. Remember, an R value that is very close to either -1 or +1 is considered very strong. Somewhere in if it were like 0.7 or something like that, then I could say, it's like moderately strong. If it was like, 0.3, it could be like, it's kind of weak. And then if it was like 0.1 or 0, I'd be like, yeah, that's very weak. Something along those lines. But look at that. That's very strong. That's a very strong correlation coefficient. Oh my gosh. It's amazing. This line of best fit is almost perfect. But let me look at the residuals. If I were to look at the residual plot, look at this. This one's going to be a bit more obvious than others. If I looked at the residual plot, zoom 9. Look at that residual plot. This one clearly has a pattern to it. See, what happened was I created a scatter plot that I knew was going to look straight enough. And it was going to have an R value that was calculated to be very strong. But I knew that the residual plot was going to clearly have a pattern. Clearly. If you looked at my actual data points right here, here are my actual data points. All I did was I typed in 1, 2, 3, 4, and I just put in the squares. I put in a quadratic scatter plot. I made it look quadratic. I actually made it quadratic. It's actually pretty messed up that I did that. But that's what this thing does. Wow. So wonderful. Okay. Now, there is one more thing that I would like to talk about before we attempt to knock out a practice quizzes. And with this practice quizzes, I am going to make the answers available to you. But I got to talk about R squared. It's the last thing I got to write down today. R squared. Typically, R squared, when you write R squared, it's going to be capitalized. That's just the notation that they chose. It's how do you calculate it? Well, you square the R. Yeah, you do. But whatever. There are technically multiple definitions, multiple ways that you could express R squared. R squared is always going to be presented to you as a percentage. Like, 98%. Okay, all right. There are 3 example definitions that I'm going to give you. The third one is the one that is most typically used, but I need you to be aware of the fact that R squared could be expressed in different ways verbally. You'll see what I mean in a moment, hopefully. So there are 3 ways that I'm going to do this. First of all, R squared. Remember, it's a percentage. Percentages, decimals, they could also be referred to as fractions. R squared, you could say, is the fraction of the data's variation that is accounted for by the linear model. Now remember, I'll read that again in a moment. Now remember, when you're doing a scatter plot, there is variation. There is variation above the line of best fit, below the line of best fit. Nothing ever lines up perfectly. If if everything were to line up perfectly, then r squared would be 100%. I mean, it's accounted for everything. But it's usually not 100%, like 95%, 80%, something like that. It's the fraction of the data's variation that is accounted for by the linear model. Your hope is that you have a pretty high percentage. Not always going to be the case. Second definition. R squared measures how successful the regression is in linearly relating y to x. Move that over a little bit. I'll read that again. R squared measures how successful the regression is in linearly relating y to x. It's a success rate. If you have an R squared at 98%, that's pretty darn successful in linearly relating y to x. Yeah, good for you. If it's at like 10%, you're like, oh crap. Yeah, that wasn't very successful at all in linearly relating y to x. But that's what you could define it as. And again, if you see any verbiage that says something like that, like, oh, I was like 50% successful in linearly relating y to x. Oh, you're talking about r squared. Yes, talking about r squared. And finally, the definition that is most typically used. Most typical or most typically used or something along those lines is this. If I could actually find the button that I need here. Hold on. Oh, there it is. Good. It is the percent of the variation of y. And again, I wouldn't always say y. I would usually say like whatever variable it is. But it's the percent of the variation of y that is explained by the linear model on x. It is the percent of the variation of y that is explained by the linear model on x. This is what r squared is. Now, any of these definitions, like the funny thing is, whenever you see like a definition like written out, let's say on like an open-ended or multiple choice or whatever you see in the textbook or whatever, they may use variations of these three things. They might use multiple variations, including mixing and matching various things in here. Let me repeat that one more time, by the way. R squared is the percent of the variation of y that is explained by the linear model on x. Now, just one tiny little note I want to put on this little r squared thing here. R squared, another way, the verbal definition of r squared, not the verbal definition, the verbal kind of notation of it. It is the coefficient of determination. I ran out of room there, but I'm going to read that again. Let me zoom in on that. R squared is also known as the coefficient of determination. So again, if they ever refer to, oh, the coefficient of determination was, oh, you're talking about r squared. And if you're talking about r squared, then you could be talking about the verbiage in any one of these three definitions that I've given you today. R squared is a measurement of, again, how successful it was, how much of the variation is accounted for or explained by the linear model. something along those lines. And again, it's more of a verbal thing that I need you to be able to recognize. And then, if you have r squared, the value of r squared, you could potentially calculate the value of r. It's just that then you would need to know whether it was a positive r or a negative r. That could be determined by the direction on the scatter plot. Obviously, r is positive or negative depending on what the slope should be. R squared, because of it's being squared, is always going to be positive. Always, always, always. Okay, here's what I need you to do. You have a little time left, and I want to try to knock out a quizzes. Now, again, this is a practice quizzes. This is a practice quizzes. The class period may end before we finish this up, but I'm going to make sure that the questions will tell you, whether or not you got it right or wrong. And there it is. Show answers during activity, show answers after activity. You will be able to review the questions after the quizzes. So let's see. Yeah, get rid of redemption questions. That'll save a little time. Anyway, chapow. I would like you to join this quizzes. Oh no, Mr. Markey, I can't see the number. I know. I'm going to write it on the board. I'm going to type it into the chat. Okay. It's 668114. I would like you to join as soon as possible. Now, even if the class period does end and I need to move on to my next class, which I will have to, I will leave this quizzes open for you to finish. As I said, it will tell you whether or not you got the question right or wrong. And when your quizzes is done, you can leave the window open and you can review and see, okay, this one I got right, this one I got wrong. I purposefully did that because I knew I was going to be running a little short of time today. So please keep that in mind. Even if I do have to sign off, I'm going to keep the quizzes open so that you can finish it. I don't know. I like hearing those pops. The pops of people joining the quizzes. So much fun. Just a reminder, as you guys are joining this quizzes and getting ready to do battle with each other. I don't know, whatever. I think I turned the leaderboard on too, so that you could see that. Whatever. You do have a page in the book that is due for me today, based on the stuff that we've been doing with LinReg. I do have a major that is going to be due on Monday. As I said at the beginning of class, due Monday. Now, mind you, I'm going to have it due Monday at 7 a.m. But that major is going to consist of partial multiple choice and partial open-ended. So I want you to be ready for that. As people are joining this quizzes, I'm going to give you another 30 seconds to join. 30 seconds to join. Again, I put the code into the chat now, so I wrote it on the board, 668114. I'm going to click start so you can get this thing moving. Of course, yeah, this is just a practice. The one that you're doing right now is a practice. Just please keep that in mind. All right, let's get them started. Now, even if I click start and you have not joined yet, that code is still good. You could still join it. They have the code at the top of the screen. Let's get them started. Ooh, let me turn down that volume. There we go. Now, like I said before, class period is going to end, and I'm going to end the live stream, but I am going to leave the quizzes open for those of you that need to finish it. And of course, at the end of your quizzes, you should be able to see the questions and which ones you got right, which ones you got wrong, and review those on your own. As I said, the textbook page is due today, 2 o'clock. I am going to be assigning the major, but it won't be due until Monday at 7 a.m., which will include a multiple choice aspect and the free response. I am going to, I'll probably assign those before I leave here today. I'm just trying to figure out what time during whatever. It'll be today. But anyway, if you have any questions, email me. Like I said, finish the quizzes. If you haven't, I'm going to leave it open. But yeah, have fun. See you later. Bye-bye.